In this question, we're told that a parallelepiped is determined by certain vectors, and we want to determine the other vertices. Well, the vectors that determine the parallelepiped are OA, OB, and OC. O can be given the coordinates 0, 0, 0. A is 9, negative 7, negative 1. B is negative 3, 2, 5. And C is 10, 1, 6. Now, I drew the parallelepiped this way. You might look at that and say, but how do we know it's a cube? Like, this looks like they're 90-degree angles. How do we know that they're 90 degrees? The answer is we don't, and they're almost certainly not 90-degree angles. But we're just drawing this to give us a perspective of the points' locations in relationship to each other. So we can actually draw this as though it's a rectangular prism with no loss in generality. We just need to know that OB needs to be the same as CG. So, and like AD needs to be the same as OC, etc. We just need to know these points in relation to each other. So knowing that AD has to be the same as OC, and knowing that OC is the vector 10, 1, 6, we can easily calculate that the point D must be 19, negative 6, 5. Because if D is the point 19, negative 6, 5, then 19 minus 9 is 10, negative 6 minus negative 7 is 1, and 5 minus negative 1 is 6. And we've got equivalent vectors that are obviously parallel. Now, AE needs to be the same as OB. OB is negative 3, 2, 5. So that means that the coordinates of point E must be 6, negative 5, 4. Because if E is 6, negative 5, 4, then 6 minus 9 is negative 3, negative 5 minus negative 7 is 2, and 4 minus negative 1 is 5. Negative 3, 2, 5. By similar rationale, we know that BG must be equal to OC. So here's BG, and here's OC. OC is 10, 1, 6, so G must be negative 3 plus 10, which is 7, 2 plus 1, which is 3, and 5 plus 6, which is 11, meaning that 7 minus negative 3 is 10, 3 minus 2 is 1, and 11 minus 5 is 6, so that this vector is 10, 1, 6, and is the same as this vector. And finally, we know that GF has to equal OA. Here's GF right here, and OA is right here. A is 9, negative 7, negative 1, so the point F must be 16, negative 4, 10. So that 0 to 9 is 9, 7 to 16 is 9, 0 to negative 7 is negative 7, 3 to negative 4 is negative 7, 0 to negative 1 is negative 1, 11 to 10 is negative 1. And you might say, well, how would we know which particular paths to take? And the answer is it doesn't matter. To get to the coordinates of point F, we didn't have to say that GF is equal to OA. We could have said that EF is going to be equal to BG. Had we done that, we would have seen that EF is going to have to equal 10, 1, 6. 6 plus 10 is 16, negative 5 plus 1 is negative 4, 4 plus 6 is 10. So as long as you stay consistent and use the proper inherent logic, it doesn't matter which parallel sides you set equal to each other, as long as you realize that the vectors on opposite sides of these parallelograms are all equal. These 4 vectors are all equal, these 4 vectors are all equal, and these 4 vectors are all equal.